Towards the end of the Cretaceous period, around 66 million years ago, there was a massive mass extinction that wiped out roughly 75% of all plant and animal species on Earth. This included the dinosaurs, which are so iconic that they're basically synonymous with the word extinction. But did you know that this mass extinction wasn't caused by an asteroid impact? In fact, it was actually caused by multiple smaller events that were taking place over a span of millions of years, including a massive volcanic eruption in India, rising sea levels, and a gradual decrease in the Earth's average temperature. And while these events were disastrous for the majority of life on Earth, there were some winners, animals who were able to use the dying world to their advantage. And one of the biggest winners was a crocodilian named Boreapelta mark-michelli, or more simply, Boreapelta. But before we get into how this prehistoric croc managed to survive the mass extinction, let's talk about how we discovered it in the first place. Fossil evidence suggests that crocodilians have been around since the Triassic period, but the earliest fossils we found are from the Jurassic. So we really don't know much about what crocodilians looked like before the Jurassic. So when Wendy Ceratops, a paleontologist at the University of Montana, found a fossil in North Dakota in 2000 that she believed was from the Cretaceous, she was very excited. At first, she thought it was a relative of the dinosaurs, but after looking at its skull, she realized that it was something else entirely, a relative of today's crocodiles and alligators. This discovery was huge because it gave her an opportunity to learn more about the evolutionary history of crocodilians. In 2009, she published a paper describing the new species she had discovered, Boreapelta mark-michelli, or just Boreapelta. She chose the name Boreapelta because the specimen was found in the northern part of the continent of Pangaea, hence the name Boreo, which comes from the Greek word for north, and pelta, which means skin, referring to the animal's reptilian nature. Mark Mitchell was chosen to honor the technician Mark Mitchell, who spent almost 800 hours carefully cleaning and removing rock from the fossil. So why does any of this matter? Well, because Boreapelta turned out to be a lot more than just a new species of prehistoric crocodile. It was actually a representative of an entire group of prehistoric crocodilians. Although Boreapelta is called a crocodile, it isn't technically a crocodile. Instead, it's a member of a group of prehistoric crocodilian relatives known as the Meso-Eucrocodilia. This group includes all modern crocodilians, which are made up of crocodiles, alligators, caimans, and gharials, as well as a bunch of extinct relatives. And that's where things get a little complicated. As far as we can tell, Boreapelta is the oldest member of the Meso-Eucrocodilia that has ever been found. This means that when it lived, it would have been around 40 million years before modern crocodilians showed up in the fossil record. So, needless to say, it would have been pretty different from the crocs and gators we know today. When Boreapelta was first discovered, it was initially thought to be more primitive, more lizard-like. But it turns out that it was actually quite advanced, possessing several skeletal features that are only found in modern crocodilians, such as a thickened area of cartilage in its tail that would have acted as a counterbalance to its long, narrow head. Based on these features, scientists now believe that Boreapelta was probably a capable swimmer and active hunter, even though it was only about 3 feet long. This is significant because it shows us that the ancestors of modern crocodilians didn't just appear fully formed in the fossil record. Instead, they evolved gradually, changing very slowly over tens of millions of years. And it also suggests that these changes happened relatively quickly on an evolutionary timescale. In fact, researchers believe that most of the major groups within the Meso-Eucrocodilia, including the ancestors of today's crocodiles, alligators, caimans, and gharials, all arose during the Cretaceous just a few million years before the mass extinction at the end of the period. But despite the fact that this group experienced a burst of evolution right before the mass extinction, it wasn't particularly diverse. For the majority of the Cretaceous, the Meso-Eucrocodilians were relatively small, averaging between 3 and 9 feet in length. The reason for this is unknown, but it may have had something to do with the large predatory dinosaurs that dominated the land during this time. Regardless, the situation changed dramatically when the asteroids hit. The asteroid impact at the end of the Cretaceous killed off the dinosaurs and allowed Meso-Crocodilians to diversify and spread across the globe. As far as we can tell, the only other crocodilian group that existed at this time, the phytosaurs, died out during the Cretaceous, perhaps because they were already going extinct by the time the asteroid hit, or maybe because they were unable to adapt to the sudden environmental changes. Either way, this left the Meso-Crocodilians as the only crocodilians on Earth, and they took full advantage of this new opportunity. Over the next few million years, they radiated into a wide variety of ecological niches and became much larger. In fact, the ancestors of today's crocodiles and alligators grew to lengths of over 30 feet. So, while Boreapelta itself died off along with the rest of the non-avian dinosaurs, its descendants went on to dominate the planet. But why did they become so successful? Well, we don't know for sure, but it likely had something to do with their size and their teeth. After the mass extinction, the average global temperature dropped by 5 degrees Celsius, which would have resulted in colder climates and fewer large lakes and wide, shallow rivers. Crocodilians adapted to these changes by becoming smaller, more slender, and better at hunting in fast-flowing streams. They also developed thinner, more serrated teeth that were great for catching fish. In contrast, phytosaurs were still large, sluggish, and specialized for life in the water. So they probably struggled to adapt to the changing environment, and that might explain why they disappeared. But if the Meso-Crocodilians were so successful, why aren't they around today? Well, as far as we can tell, they are around today. After all, modern crocodilians are part of the Meso-Crocodilia. Perhaps the term crocodilians is more appropriate than crocodiles because crocodiles and alligators are simply two of the many types of crocodilians alive today. But despite the fact that they've been around for over 100 million years, crocodilians haven't changed much. You could look at a dinosaur and tell that it was related to a bird, but the difference between a Boreapelta and a crocodile is less obvious. What makes this even weirder is that other than the mass extinction at the end of the Cretaceous, crocodilians have experienced very little major change in their environment. Sure, continents have moved, sea levels have risen and fallen, and mammals have taken over a lot of ecological niches once occupied by dinosaurs. But for the most part, the world hasn't changed much over the past 66 million years. And yet crocodilians have somehow managed to stay basically the same. But maybe they have changed, maybe just not obviously. Scientists are currently trying to find fossils of early modern crocodilians in order to study their evolution. One of the people working on this project is lead author of the original Boreapelta paper, Wendy Sloboda. Now, a curator at the Royal Tyrrell Museum of Paleontology, she says that while it's unlikely that we'll find anything as spectacular as Boreapelta, she hopes to find something just as interesting. Because despite the fact that crocodilians haven't changed much, we still don't know a lot about them. We don't know for sure when modern crocodilians appeared in the fossil record, and we don't know exactly what the ancestors of crocodiles, alligators, caimans, and gharials looked like. Maybe one day we'll find a fossil that will help us understand this amazing group of animals a little bit better. And speaking of amazing animals, thank you so much for watching, and I'll see you next time.